Have you ever just stopped and wondered how your computer actually works? I mean, it really feels like magic, doesn't it? There's this silent, invisible force inside just perfectly orchestrating this whole symphony of hardware and software. Well, today, we're not just going to pull back the curtain, we're going to meet the magician. I mean, seriously, think about what you're doing right now. You've probably got a bunch of browser tabs open, maybe some music is streaming, notifications are popping up. How does one single machine, with just one central brain, do all of that at once without completely falling apart? This isn't just a neat feature. It's one of the most brilliant and fundamental puzzles in all of computer science. Today, we will deeply understand Chapter 1 of Silberschat's Galvin and Gange, an introduction to operating systems.
All right, so let's get into it. Here's our roadmap for solving this puzzle. First, we're going to meet the master conductor of this whole orchestra. Then we'll see its incredible juggling act, how it manages its main workspace and its massive library of information. And finally, the best part, we'll uncover the secret that gives it absolute control over everything inside your machine.
So that master conductor, that unseen ruler we're talking about, is, of course, the operating system. You know it as Windows, Mac OS, Linux, Android. Formally, it's the core software that manages every single piece of the computer's hardware and all of its software resources. It provides the very foundation that all of your applications run on.
Now, this is such a fantastic analogy. The operating system itself doesn't browse the web for you, right? It doesn't edit your photos. Just like a government doesn't build the houses or farm the food itself. Instead, it creates the structure, the laws, the roads, and the environment that allows all the other programs, the citizens if you will, to do their jobs safely and efficiently. We can look at the OS from two totally different angles. From our point of view, the user view, we just want it to be easy to use. We want convenience. Click a button, something happens. But from the computer's perspective, the system view, the OS is a ruthless resource manager. Its job is to allocate precious resources like CPU time and memory as efficiently and as fairly as possible for every single program running. And believe me, those two goals, making things easy for you and making things efficient for the machine, are often in direct conflict. So this shows you exactly where the OS fits in the grand scheme of things. Think of it like a layer cake. At the very bottom, you have the raw hardware, the metal and silicon. At the very top, you have the users, us. And right in between are the application programs we use. The operating system is that crucial layer sitting right on top of the hardware, acting as the intermediary. It's the universal translator and the chief of police for the entire system. Okay, so let's get into its first huge job, juggling. Every single thing your computer is doing, from tracking your mouse movements to running a massive video game, is a task. And the OS has to manage all of them, creating this seamless illusion that everything is happening all at once. And this is where the scale just becomes mind-boggling. On a modern computer, we're not talking about 2 or 3 tasks. We're talking about hundreds, maybe thousands of background services and active applications all running at the same time. So how on earth does the OS keep them all in their own little worlds, running smoothly without bumping into each other and causing total chaos? Well, the secret starts with this really important concept, a process. See, a program sitting on your hard drive is just a passive file. It's like a recipe in a cookbook, just a list of instructions. But when you double-click that icon, you're asking the OS to turn that recipe into a process. The process is the living, breathing instance of that program. It's the act of actually cooking the meal. It's the fundamental thing the OS actually works with. And the OS is the ultimate process manager. It's responsible for bringing these processes to life and for killing them when they're done. It puts them to sleep when they're waiting for something, and it wakes them back up. Most importantly, it decides thousands of times per second which one gets to use the CPU right now. That's called scheduling. It also has to provide safe ways for processes to talk to each other without messing everything up. Okay, let's move on to the next critical job, managing the computer's workspace. We're talking about its main memory, or RAM. The best way to think about RAM is like a workbench. You can only work on the tools and materials that are currently on your bench. Now, you have to understand the enormous difference in speed we're talking about here. The CPU is ridiculously fast, like a Formula One car. But your main hard drive, by comparison, is like walking. It's incredibly slow. So for a process to actually run, its instructions and its data absolutely must be moved from that slow, long-term storage, the library, onto the workbench, the main memory, or RAM, where the super-fast CPU can get to it instantly.
The OS is the manager of this priceless piece of real estate. It keeps a super detailed map of every single byte of RAM. It's constantly deciding which process gets which spot on the bench, moving data around as needed, and, this is key, cleaning up the space the very instant a process is finished with it so someone else can use it. So if RAM is the temporary workbench, then your hard drive or your SSD, well, that's the permanent library. This is where all your programs and all your data live for the long term, when they're not being actively used. Now, the idea of a file is maybe one of the most brilliant and beautiful lies in all of computing. A physical disk is a really complex mess of spinning platters, magnetic heads, tracks, and sectors. It's complicated. But the OS hides all of that ugly complexity from us and gives us this simple, elegant idea, a file. It's just a named container for information. Isn't that clever? It makes everything so much easier. The OS is the master librarian of your entire system. It knows exactly where every single book, every file, is located on the shelves. It keeps track of all the empty space, it helps you organize things into folders or directories, and it handles the creation and deletion of all of your precious data. All right, so we've seen how the OS manages processes, memory, and storage. But how? How does it enforce its rules? What actually stops one misbehaving program from scribbling all over another program's memory and bringing the entire system crashing down? This is the secret to its power. So here's the fundamental dilemma. The OS needs total, privileged, ultimate access to all the hardware to do its job. But if your web browser also had that kind of power, a single bug in a website could wipe your entire hard drive. So the crucial question is, how can the OS have all the power without giving that power away to every random application? The solution is this brilliant partnership between the operating system and the CPU hardware itself. It's something called dual mode operation. Here's how it works. All of your applications, like your browser or your music player, run in a restricted user mode. Think of it like a sandbox or a padded room. They have very limited permissions. But the core of the OS, the kernel, runs in the all-powerful, privileged kernel mode with complete, unrestricted access to every single part of the machine. So what happens when your app needs to do something it's not allowed to, like read a file from the hard drive? It can't do it directly. Instead, it has to politely ask the OS for help. It does this by making a formal request called a system call. This call triggers a special hardware event called a trap, which instantly and safely switches the CPU from the limited user mode into the powerful kernel mode. Now the OS is in control. It performs the task on the app's behalf, making sure everything is safe, and then the hardware switches right back to the safe user mode before giving control back to the application. And that is the absolute key to everything. A system call is the one and only official, secure doorway into the OS's powerful kernel mode. It's how applications respectfully knock on the door and ask for permission, rather than trying to kick the door down and take control themselves. Now, it's easy to think that all this stuff is just about your desktop or your laptop, but what is truly amazing, what's so cool about this, is that these fundamental principles, managing processes, memory, storage, and protection, are absolutely universal. They apply everywhere. The operating system in your smartphone? Yep, it does all this. The massive systems running inside a Google or Amazon data center that power the cloud? You bet. Even the tiny little OS in your car's navigation system or in your smart TV, they all work on these exact same core concepts. They all juggle processes, they all manage memory, and they all use some form of a privileged mode to maintain control. So the next time you're effortlessly switching between a dozen different apps or you save a document without a second thought, just take a moment to appreciate that unseen ruler working tirelessly beneath the surface. It is the invisible yet completely essential foundation of your entire digital life. And that leaves us with a fascinating and maybe a little terrifying thought. What would that chaos even look like if, for just 1 second, its perfect juggling act were to fail?